Hello, I've got an easy one for you today. All right, lesson 6, right? This is lesson 6. So let me make sure this is lesson 6. It is. Okay. We're going to look today at differentiability, or whether or not you can differentiate something. So differentiate or differentiability. Woo! Okay. So we've discussed that if you can differentiate something, you are taking the derivative. So if something is differentiable, then you can take its derivative. If it's not differentiable, then you cannot take its derivative. So therefore, whether or not you can differentiate or not differentiate something is discussing a function's differentiability. Whew, that's quite the tongue twister. Okay, so there's this whole conversation about, is it non-differentiable or just not differentiable? I don't know. I think it doesn't matter. Either way, not all functions can be differentiated. That means they do not all have a slope or a derivative. Remember, a derivative is a formula for slope, right? So if a function doesn't have slope, then it can't have a derivative, right? It can't have a formula. So if the slope doesn't exist, then you can't have a formula to find the slope. Therefore, you can't have a derivative. And I know you're thinking that doesn't make any sense, but it does. And there are 5 specific cases where you cannot differentiate a function. So look at this. I'm going to use a real graph today. Aren't you excited? All right, so there are 5 situations. Here is situation number 1. That doesn't even look like a 1. Okay, situation number 1. If you have points of discontinuity, so let's say we've got a function that does this. Let's say we have a function that jumps. It doesn't matter if these are holes, if those are filled in, not filled in, it doesn't matter. If we have a point of discontinuity, so number 1, point of discontinuity, then we cannot have a derivative. So let's look specifically right here. Let's look at this point here at -1, at x equals -1. If you were trying to find the slope of this at -1, how could you find a slope? Like if you were trying to draw a tangent line, would it go here? Would it go here? Would it go there? Would it go here? Would it go here? There's no way to draw one tangent line that would only fit in one way. So if we can't draw a tangent line, then we can't have a slope. So therefore we can't have a formula. So therefore there can't be a derivative. So you can take the derivative anywhere in this function except right here at x equals -1. It is not differentiable at that point because there's a point of discontinuity. Make sense? Okay, let's look at the second issue. What if we have, here's number 2. Oops. What if we have something that looks like this? What if we have something that is doing this? Now, I know this isn't a function, it's a sideways parabola, but what if we're looking at x equals 2? If we try and go draw our tangent here at x equals 2, we're going to end up with a vertical line. Now, what do we know about the slope of vertical lines. Well, it doesn't exist. So therefore, this is not differentiable because it has no slope. So the reason number 2 that we would not have a derivative and it would not be differentiable is because of a vertical tangent. So there's our second reason. Okay, reason number 3 that we would not have a derivative and something would be not differentiable would look something like this. Let's say we have this type of function. Do you remember these? What causes this? Our good friend, absolute value. And so if we're looking specifically at x equals 1 right here, and we are looking at this particular spot on the graph, how would you draw the tangent here? Does it draw here or here or here or anywhere? There's too many different ways, or maybe it's even flat at the bottom. So this is called a corner. No derivatives at corners. Now, very similar to a corner is our good friend number 4. In this one, we haven't done too much work with, but it looks something like this. Sometimes we'll get a function that does this. Kind of looks like one of those birds when you draw a stick figure bird. This is the same situation as that corner, except it's not really a corner because, well, it's not a V. And this is called a cusp. And for the same reasons with the corner, we can't have a derivative at this. How would you begin to draw a tangent line? So number 4 reason to not have a derivative and not be differentiable is a cusp. And then the final one is something we see a lot in piecewise functions, is something that looks like this. What if we do this? Man, my drawings are on point today. So this whole function has derivatives all in here. We can draw tangent lines, we can find slope. It's all well and good. But what about right here? Same deal. How do you begin to draw a tangent there? How do you begin to find slope of that? Well, you can't. So this is reason number 5. And it is called endpoints. If you've got a restricted domain for whatever reason, for some reason you've decided to cut off this graph, you've created endpoints, and therefore you cannot have, the function is not differentiable here at x equals, let's see, what is this? X equals -3 and x equals 1. It is not differentiable because of endpoints. So, full recap, 5 reasons that it's not differentiable. And those reasons are, number 1, point of discontinuity. Number 2, vertical tangent. Number 3, a corner. Number 4, a cusp. And number 5, an endpoint. Ta-da!